In this Relief Maker video, we're going to talk about exporting your relief in one of various 3D formats. We have a relief that's already been generated, and we'll go to File, Export Relief, and we can see that we have three 3D formats available: OBJ, STL, and STEP. The first thing we'll talk about is the OBJ and STL because they share identical user interfaces, and the only difference between them is the format. Let's go ahead and select STL in this case, and we'll just name it something. And here we see our first look at the new export options. So the first thing that we can do is we can define the size and the units. And unit definition here doesn't really mean a lot because STL and OBJ are unitless. And so really the thing that matters is the 10. So your options for the width are going to be the relief width, height, and depth, or the total width and height. So relief width, height, and depth look at the 3D model, and it only cares about the extents of the relief itself. It doesn't care at all about the backplane. So if you know that when you bring this into your CAD software, that this dog needs to be 4 centimeters wide, irrespective of the background, well, you might choose relief width and change that to 4. And then when you bring it into your CAD software, you'd say this thing is in centimeters, interpret it correctly, right? Likewise, if you want everything, including the backplate, to be a certain width or depth or height, just choose total width or total height. Now, in terms of the surrounding geometry, this determines the density and whether the surrounding geometry even exists. So for a dense object, the resolution of the relief, which will always be very fine, and the resolution of the backplate will have equal resolutions. And this can be good, for example, if you're going to bring it downstream into a sculpting workflow and you want to have, very smooth ability to modify the edges where this might meet the backplate. If you're more worried about file size, sparse might be better for you because sparse is going to have the relief itself be very fine with a much decimated backplate, and that's going to dramatically decrease your file size. But for certain kinds of workflows, especially sculpting being a good example, it may make sculpting the edges of this more complicated later. And so it just depends on your workflow. And then foreground only removes the backplate entirely and just exports a 3D model of the relief itself. Solidify allows you to make a backplate and turn this into a solid. And so that's really good for 3D printing, for example, or some CNC machining, depending on what you're trying to do. And so you can, if you're defining your units, you can define the size of the base very explicitly, for example, 1. If you're not defining your units, you have the option to scale whatever the longest edge of this thing is. And for squares, it'll be the same. But if it's a rectangle, you can scale everything to be according to some amount of world units and give the base a percentage of that value. So at a high level, you're choosing how big your file size is in decreasing order of file size. You're choosing whether you want a backplate, how big this thing is. And when we look in Blender, we can kind of get a quick idea of the results that we're going to get. So we can see for dense, this is a really dense mesh, 1024 by 1024. And the backplate and the relief itself are the same level of density. If I choose to view sparse and go into edit mode, the dog himself is very dense, but the backplate is much more decimated, dramatically reducing the file size. Foreground is just the dog itself. It will always be at the same level of density. And then base allows you to create a solid. And in this case, we made a really thin solid box. But this exports a solid geometry. And if we go into edit mode here, you can see that we have sidewalls. And so that's going to export a watertight OBJ or STL. Now let's talk a little bit about the brand new and 3.0 feature, Step Export. This is an absolutely huge feature because it allows you to easily bridge the gap between your mesh files, your reliefs, and CAD software. So now you can very easily bring things into Libre Design, Inventor, SolidWorks, any of these things, and incorporate these into larger designs. Let's go ahead and go to File, Export Relief. We'll choose Step, and we'll see we have a few options here. Sample every X pixels basically says for whatever relief size we're at, in this case 1024 by 1024, we want to look at every single pixel, every 5 pixels. It's important to note that as your relief size increases, your step file will increase in size dramatically, right? And so if you're trying to bring a 4K step export in, it may be 2 gigs, right? Depending on the model that you're using. And so this allows you to say, hey, I know I made this relief in 4K, but I don't want the step export to be that dense. Maybe look at every 5th pixel or every 4th pixel. And that'll take the effective resolution down by a factor of 4 in this case. For 1024 by 1024 and lower, you can probably feel free to leave it at 1, but just be aware as this number goes down, your resolution goes up, file size goes up. And the inverse is also true. B-spline max degree is something you probably don't need to worry about. In theory, higher values are a little bit blurrier, although you probably wouldn't be able to tell. And they might have a little bit higher file size, 5%, something like that, although you probably won't be able to tell. Generally speaking, just leave this at the default. Play with it if you want to, and then you can see if it matters to you. Now let's talk a little bit about chunk size. It's easier to show you rather than explain this. So I'm going to go ahead and jump into some CAD software, in this case, Libre Design. And here we see we have the exported step file opened up. And when yours opens up in Libre Design, for example, it may not look like this. It'll probably look like this. And that's because the 3D model, the relief, has been broken up into tiny chunks. But chunk size determines how big these squares are. So our chunk size here of 32 corresponds to the width and height of these squares. If we think of the top as being, quote, 1024 pixels, like it is in Relief Maker, then this would be 32 pixels. So the higher the chunk size, the bigger the squares. You might be tempted to make everything a single square, or make a chunk size that is, where you have 4 squares. Just be aware that we get a lot of things for having a reasonable chunk size, most notably file size. So all of the stuff in the background that's not part of these chunks is rendered internally at a much, much lower resolution. This dramatically decreases your file size. So having detail only where detail is required is one of the benefits of using chunks. Another benefit is that some software simply won't open something this dense in terms of data if it is a single defined surface. And so that's why we break it up to make it a little bit easier for multiple softwares to use it. Anyway, we have our model available. We can do things to it in CAD software. Maybe we want to put, a circle. Make it through. Right? So we can do real useful things to this in CAD software, make it part of a medallion, flesh out, the rest of our coin design, whatever we're going to do. I would suggest leaving chunk size at auto and letting the software just figure it out based on the resolution and how many pixels you're skipping. This is where we get into size in units, and this is real world sizing in units. So if you choose 10 millimeters for the total width, for example, then this from here to here in the step file is going to be 10 millimeters. These are unit full files, and so defining this here actually does matter. So just pick whichever one is appropriate for what you're doing. And then if you want to put it on a solid, which I would recommend for most CAD software, go ahead and export as a solid on a base and choose the units that you'd like for the base. And that's it. Now you have access to Relief Maker reliefs in all of your CAD software. Just a few caveats with this. Step file format was not really designed for this kind of data, so your mileage may vary. Some kinds of models look amazing. Some lose some fine details where you're in Relief Maker and you see, skin details and pores. I mean, you get into the CAD software and you've lost a lot of that. So you really have to understand some of the limitations of using step files to transfer this kind of data. But if you do a 1K or a 2K at a reasonably low pixel count and your CAD software is able to import that much data, you can actually get a lot of pretty good results. I think you'll be surprised. Just have reasonable expectations and you'll be good.